These are some of the homework problems from section 2.6 in the Advanced Placement Calculus course. Here we have a product, so it's going to involve a product rule. To do the product rule in 31, I bring down e to the 2x times the derivative of arc sine, which u prime over 1 minus u squared, plus the other way around. Bring down the arc sine of x times the derivative of e to a power is e to the same power times the derivative of the power. So what I've done here is a product rule. U times v becomes u v prime plus v u prime. Again, that's a product rule. So this becomes e to the 2x over the square root of 1 minus x squared. This would be 2e to the 2x arc sine of x. Now, if we wanted a common denominator, we could write it with a common denominator. E to the 2x is already over this. This would need that 2x and a radical, right? And times arc sine of x. I'm going to assume the textbook leaves the answer like this. They might take it to the bottom one. Let me check. Apparently what the textbook does is factors out an e to the 2x, and that's 1 over the radical plus 2 arc sine of x. I think that's the answer the textbook has. Okay, I'll attempt to do them in the sequence they were given. 31, 35 here is next. What is the derivative of sine of u? Well, it would be cosine of u times u prime, right? Can anybody identify what I'm letting u equal? Good, arc cosine of t. Can you do u prime? That would be u prime over radical 1 minus u squared, right? Do you agree that I'm letting u equal arc cosine of t? And this is a derivative of the arc cosine. So I'm going to fill it in. Cosine of u times u prime. What can I replace the u with? Arc cosine of t. What can I replace the u prime with? Negative 1 over radical, I think. Because it's not multiplied. I'm not using a product rule because this is not sine times, it's sine of. It's like the square, it's a mathematical operation like a square root. Square root of 9, not square root times 9, right? It's a square root of 9, just like this is a sine of the arc cosine. Anyway, cosine and arc cosine eliminate each other, leaving me the t. It's negative, and the radical's on the bottom. So there's your derivative, probably the easier approach. I could have got it by drawing a triangle and doing it algebraically as well. If I did it algebraically with a triangle, I would have to realize that arc cosine means the angle whose cosine is t. So what I'm going to do is I'm going to make a right triangle with an angle, and I'm going to make cosine, which is adjacent over hypotenuse, t. So is the cosine of theta t? Adjacent over hypotenuse. Find the missing side using Pythagorean theorem. With practice, it'll become pretty easy. Now I want the sine of this. So what is the sine of this? Is the sine opposite over hypotenuse? So is this another way of writing y? Now let's take its derivative. The square root is a 1/2 power times the base to the 1 less power times the derivative of the base. Well, the 1/2 and the 2 are going to cancel, leaving me a negative t over the square root. And hopefully this matches the same answer I got the other way. Hopefully these are equivalent. Okay, we did 35, a couple of different approaches. Let's find the next biggest number. Apparently is 39. It's a little long, so please try and stay with me. I'm going to keep the 1/2 out front, and now I'm going to keep that 1/2 and apply a property of logs. Can I do log of the top minus the log of the bottom? And then I still have this out on the side. And that 1/2 applies to both of those. I have not taken the derivative yet, so I still call it y. All I did was a property right here. And the natural log of a over b could be natural log of the top minus natural log of the bottom. And that's how I got this. It's just a property of logarithms is all. Now I'm going to take the derivative. Well, why did I do that? Was to make my differentiation process easier. Because now I know that if I have the derivative of ln of u, the derivative of ln of u, natural log of u, is u prime over u. So this is going to be u prime over u. U prime over u. Does anybody know the derivative of arctangent? Well, it'd be u prime over 1 plus u squared. So I'm going to stop a moment, see if I can answer any questions. Okay, I'm still going to keep this 1/2 out front as a constant factor. I still have this 1/2 out here. What would be a common denominator for these two denominators? X plus 1 times x minus 1. And you still have this over here. On top, I need this denominator. So, you have x plus 1. What do you need in the bottom? You need an x minus 1. So you multiply by a fancy form of 1. Don't forget to use parentheses when you subtract. What is the second one missing? It has an x minus 1. It needs a x plus 1. So that makes this x plus 1. Cleaning up the numerator, what happens? X and a negative x add to 0. Negative 1 and negative 1 is negative 2. When you multiply your denominators, you get x squared minus 1. What I'm going to do now is I'm going to cancel this 1/2 and this 2. And I'm going to take that negative and reverse the subtraction on the bottom. Instead of x squared minus 1, now it's going to be 1 minus x squared. I did that partially because I know that I need a common denominator. What is the common denominator here? Would it be 1 minus x squared times 1 plus x squared? And there's a plus here. So what's the 1 on the left need? It has a 1 minus. It needs the 1 plus. 1 plus x squared. What about on the right? What does it need? This needs a 1 minus x squared. And that makes it 1 minus x squared. Because it's addition, the parentheses, you don't really have to, and you still have this over here. You don't need parentheses for addition, really just for subtraction. Can anybody clean this up now? Does the x squared and the negative x squared add to 0? So that gives me 2 over what? 1 minus x to the 4th, I believe. And you still have this. Give me a minute. I want to look at one thing. I think I might have misplaced something. Okay, I see a couple things. First off, this is here. So I really don't need this on the end. It's already there, right? So I think it's just this. Now, that adds to 2. Those 2's would cancel. And I should have my final answer to be this. I thought I had an extra term. I was trying to figure out what I did. But I have that arctangent derivative following down. So this is the result. Okay, let me try and be clear. I use this negative. I use this negative right here to reverse the subtraction on the bottom. So from x squared minus 1, it became 1 minus x squared because of that negative. Okay, another one of these would be like 41. This is the tangent of the arc sine. The derivative of tangent of u. So if I had tangent of u, the derivative would be secant squared of u times u prime. That's how I'm going to find the derivative of tangent of u. What am I letting u equal? Arc sine of t. What is u prime going to be? 1 over radical 1 minus t squared. So when I go to fill this in, secant squared of u, what can I replace this u with? Okay, I can replace the u with the arc sine of t. What can I replace the u prime with? Well, it would be replaced with 1 over radical 1 minus t squared. Now, this right here is secant squared of an angle. Specifically, an angle whose sine is t. So I'm going to make an angle, a right triangle with an angle, and I'm going to make the sine, which is opposite over hypotenuse, t. So the sine of this angle is now t. Find your missing side using Pythagorean theorem. Again, it will get easier with practice. And secant is 1 over cosine. So let's do secant squared. Cosine is adjacent over hypotenuse. Therefore, I'll write it down. Cosine is adjacent over hypotenuse. So what would secant be? It's reciprocal. Hypotenuse over opposite. So what's the hypotenuse? 1 over what's opposite? I'm sorry, cosine is not, it's adjacent, right? Should be hypotenuse over adjacent, isn't it? So hypotenuse over what's the adjacent? When you square 1, you get 1. When you square the square root, it goes away. And so you have 1 minus t squared to the 1. The square root is to the 1/2 power. When you're multiplying like bases, you add the exponents. So 1 plus 1/2, or 2/2 plus 1/2 is 3/2. And that's the derivative for number 41.